I'd like to go back to the idea of 3.2 representing a function, introducing to you the function notation and what a function value. If you look at the function notation, it's just a format to write an equation. I'll show you what format is in a minute. And a function value is what you actually get after evaluating that function. So let's spell check there. So let's take a look at this one right here. We used to represent an equation in this format. Y equals, for example, 3 times x plus 2. Okay, and I typically tell you that x would be what you're going to input into, and you need x to solve for y, so therefore y is your output. We can also call this the independent variable, and this is their dependent variable, as you can see, because y depends on x to get its value. So if we define, for instance, remember, if I give you a specific input to substitute to x, you can use it. Otherwise, if you are to generate your own points, you can also get your own inputs. So let's say I define x to be 5, or 5. Okay. So what it means is you take the 5, you substitute it right into x, and then you evaluate it. So that would be 3 times 5 plus 2, which is 15 plus 2, or 17. So this is a general equation, and you're solving for y with x given. Now I'm going to take the same exact format right here and convert it back into what we call a function notation. Now the function notation can take on different names. It could have you can call it an f function. You could call any alphabet, using any alphabet really. So let's call this an f function. The general format will look like this. I'm just going to give you what it will look like. So on the right hand side, notice that it is still the same thing, same rules, but on the left hand side you will see that it is now slightly different, but this represents the same thing as y, but instead of calling it y, I call it f of x. Okay, now if I want to evaluate it, what this machine or this function really doing is it's taking in. So when you were given something like this, read it this way: f is taking in an input. Okay, so f is taking an input, and you will go to the right hand side, okay, and then said, well, the input now, well, what happened to the input? You take the input, times it by 3. Okay, so you can just write f is taking an input, then times it by 3, and add 2. Okay, so notice it's taking in an input, times it by 3, then add 2. That is the exact definition of this function. Okay, or you can call machine if you want to call it that way. So what it does is, let's say I said, okay, let's give this function f, we call it function f, an input of 5. So what you do is every time you see an input, I don't care. Now please understand, this area right here is the input. Whatever the input is, you replace it. You replace the variable inside with that input. Okay, so I would prefer that you would do something like this. Remember, the definition tells you that you would take the input and you times it by 3, right? So what is your input? 5. And then you add 2 to it. Okay, so it becomes 15 plus 2. Now, for those of you who don't want to use the variable x as an input, you can certainly do it like this. F, waiting for an input. Okay, and then it will take that input, times it by 3, then add 2. You can simply convert this into the above. It makes it easier for you to recognize it, that whatever the input is, you put it in there. Okay, this is like a placeholder in a sense. It doesn't serve a purpose. The only purpose is just holding a place for the input. Okay, so I don't care whatever I give you for the input, you can certainly plug it in. So even if I do something like this, let's give you an input of r minus a. I don't care what I give you. Just understand that this is the input, and every time you see an input, you would plug it in here, times it by 3. You see how that works? Input right there. Because the definition tells you that you just plug it into the input, times it by 3 plus 2. And you can just go and simplify that way. Distribute, and that will be your simplified answer. Okay, let's try another one. Let's just make sure that you understand it. Pretend I have a G machine, and this G machine would take the input and square it. Now, you don't like this using the letter X, write it like this. G, take in the input, and whatever my input is, I square it. Okay, so here it is. G takes in an input, then based on the definition, square it. Okay, so now if I give G a 5, what it does to the 5 is going to take that 5, plug it in here, and square it, which will give it a 25. Okay, very simple as you can see. Now if you have any other questions, feel free to ask me during class time.